In this video, we are going to prove that the sum of the reciprocals of square roots 1 over square root 1, 1 over square root 2, etc., all the way up to 1 over square root 80 is between 16 and 17. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. To prove this inequality, I'm going to show that the series in the middle is between two different series. And those two different series, I've picked them to be telescoping sums. The reason I chose telescoping sums is that they're easy to compute and the result is usually very neat, as in the numbers are usually whole numbers or rational numbers. So to start off, I'm going to use this trivial inequality, which is that for all natural numbers n, square root of n is less than square root of n plus 1. Trivial, right? But now I'm going to do something tricky, which is I'll first add both sides by square root of n, so then the left hand side will become 2 times square root of n less than square root of n plus 1 plus root n, and then I'm going to take the reciprocal, which gives 1 over 2 times square root of n. It's larger, not smaller, but larger, because we have taken reciprocals. 1 over square root of n plus 1 plus root n. Now, on one hand, I can move the 2 at the left to the right, so then the right hand side becomes 2 over square root of n plus 1 plus root n. On the other hand, I can do something like rationalization on the right side by multiplying both the numerator and denominator by root n plus 1 minus root n. And then now the right side becomes 2 times square root of n plus 1 minus square root of n, whereas the denominator, this part, becomes root n plus 1 all squared, and that's n plus 1, minus root n all squared, and that's n, which gives 1. So divided by 1 is just the number itself. That means the right side is just 2 times square root of n plus 1 minus square root of n. We've removed the fraction. And we do not have to do anything on the left because this is exactly what we want at the left. 1 over square root of n, the summed. And I'm going to do this kind of inequality repeatedly and add them up together. On the left, I'm going to add such inequalities taking n equals 1, 2, 3, 4 all the way up to 80. And this should be larger than 2 times the summation of square root of n plus 1 minus square root of n from n equals 1 to 80. But the right side is now a telescoping sum, because, for example, for the first term is root 2 minus 1. And for the second term, we have root 3 minus root 2. You can see that the root 2 cancels out. For the third term, we have root 4 minus root 3. And the root 3 cancels out. This is what we mean by telescoping. And this cancelling will go on and on all the way down to the last term, which is square root of 81, because 80 plus 1 minus square root of 80. And this minus square root of 80 will be cancelled out too. So what's left is just 2 times root 81 minus root 1. But now they are perfect squares, so we have integer values. And so that means we have 9 minus 1 times 2, and that's 16. So we have proved the lower bound. Now using a similar trick, we can prove the upper bound as well. This time I'm going to start off with root n is larger than root n minus 1 for all n that is at least 1. So then this inequality is still well defined. And then similar trick, adding root n on both sides, taking reciprocal. And so 1 over root n is less than 2 over root n plus root n minus 1, swapping the order, then multiply by root n minus 1 over root n minus 1. So then again, for the denominator, we have 1, while for numerator, we have 2 times root n minus 1. And then do the series again, summation, starting from n equals 1 to 80. Now this time we have a telescoping sum again. We have root 1 minus root 0, root 2 minus root 1, the root 1 cancels out, root 3 minus 2, and this goes on. The last term is root 80 minus root 79. So if we follow this pattern, then our given summation should be less than 2 times root 80 minus 0, because all these root 1, root 2, root 3, and so on up to root 79 are cancelled out. So then this summation should be less than 2 times root 80, and that is, by simplifying, we have 8 times square root of 5. But you may notice that this is actually not enough to give our proof, because we are asked to prove that it's less than 17, but 8 times root 5 is larger than 17. How do we know that? We can see this by rewriting this surd as root 320 instead, because we can put the 2 inside the surd, and we have 80 times 2 squared, and that's 320. And we know this is actually larger than 17. So does this mean that our argument is wrong? Actually not. If we look more closely at what we have been doing, for example, in the first term of the summation, we are actually saying that 1 over square root of 1, that's our inequality taking n equals 1, is less than 2 times root 1 minus root 0. And this is, of course, is right, because that means it's equivalent to 1 is less than 2. But do we actually need this? Of course not. So what we can do to fix this inequality, or fix our proof, is that we can only do the summation according to the inequality that we've established, starting from n equals 2. So I'm going to rewrite this 1 into 2, and I'm going to add 1 over root 1, and that's 1 at the left, so to strengthen our inequality. For the right, I'm going to only add root n minus 1 starting from n equals 2, whereas for the first term, I'll just leave it as 1. Now from this, we won't cancel out the root 1, and we'll only cancel out root 2, root 3, all the way up to root 79. So that means this 0 should be 1 instead. And then we add a plus 1 at the end. Now this time, the inequality still holds, but the right side takes a smaller value. In fact, it takes 2 times root 80 minus 1. Or I can say root 320 minus 1. And we know that this must be less than 17 because root 320 is less than 18. And so there we have the proof of our inequality on both sides, which is that the sum of 1 over root n from n equals 1 to 80 is between 16 and 17. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.